Since the privatization of the space exploration industry, there has been a lot of talk about returning to space, with several missions already in the works. This increased interest has led to the advent of numerous innovations, and these innovations have in turn led to the rapid development of the space exploration sector. However, in the past 20 years, all achievements previously attained pale in comparison to what the American aerospace manufacturing company, Relativity Space, has now accomplished. The company has completed the construction of the world's first 3D printed rocket. Yes, they've printed a rocket, and it's ready to launch. 3D printing has been used in aerospace manufacturing, but never at this scale. The company's maiden rocket is 85% 3D printed, with plans to up that percentage on their next project. How have they done this? What does this mean for the future of space exploration and Mars exploration in particular? The potential trickle-up effects are numerous. From how this will ruin SpaceX to 3D printed space stations, we cover every piece of information you need in today's video. Elon Musk is known to bring his unique and exciting ideas with him whenever he enters any sector. SpaceX has been exceptional since its inception, and while the company is credited with several great innovations that have refined space exploration, even Musk and his employees must confess that they have been outdone this time. In a move reminiscent of Tesla's gigacasting, Relativity Space has finished printing the world's first 3D printed rocket. The 35-meter, 115-foot tall Terran 1 rocket has 85% of its parts made by a 3D printer. The rocket's first launch attempt was scheduled for March 8th in the Cape Canaveral Space Force Station in Florida. Before even leaving the ground, the Terran 1 has already set 2 records. It is the largest object to ever be 3D printed, and also the largest 3D printed project to attempt orbital flight. It has taken a lot of work and incredible ingenuity to get this far, and there's still work to be done to get it into orbit. This mission will be the first time Relativity Space's 3D printed design and strategy will be put to the test. The Terran 1 was created from a necessity to reduce the cost of space travel, especially to low Earth orbit. There has been a rise in the amount of space travel and the intensity of the space race ever since the sector went private. This healthy competition is causing an increase in the demand for faster and more efficient ways of traveling to low Earth orbit. Relativity Space could not have picked a better time to launch Terran 1. The company initially planned to launch in the winter of 2021. However, this was postponed to early 2022. The business cited the COVID pandemic, as well as the need for engine and material improvements, as the justifications for the delay. And in Musk fashion, the launch was postponed a second time to early 2023. Well, it's 2023 now, and it looks like the Terran 1 will either launch this year or blow up trying. This initial launch, no matter the outcome, will serve as a guide for the company's bigger and better 3D printed rocket, the Terran R. The Terran R is expected to be reusable, and although it has a cargo capacity a little less than SpaceX's Falcon 9, it makes up for this shortcoming in several ways, which we will see later. For its 2023 launch, the Terran 1 will not carry any payload. The mission, which is dubbed Good Luck, Have Fun, is purely for test purposes. The Terran 1 took Relativity Space 7 years to get to this point, but they can be forgiven if they are able to nail the launch on the first trial, a feat no private startup has been able to achieve in the past 20 years. Relativity Space rockets are expected to redefine aerospace manufacturing and subsequently space travel. Relativity Space 3D printed technology combines a healthy dose of AI, autonomous robots, and 3D metal printing. Their goal is to produce rockets that surpass all other rockets that came before them, including those of SpaceX. Relativity's rockets are lighter, or easier to build, or made up of fewer parts, about 1/10 that of conventional rockets, require less time to build. Relativity Space says it can build a Terran rocket in 2 months compared to the 2 years it takes to build conventional rockets. Not to mention that the prototypes are faster and cheaper to make, create less waste, and finally, but maybe most importantly, modifications can be made without slow and costly retooling. Relativity's rockets sound like a dream, almost like when we saw Tesla making cars with only 4 separate parts. If you think this whole thing sounds like a sort of thing Musk would come up with, then you're right on the money. A lot of big execs at Relativity Space came from SpaceX and Blue Origin, and, like Musk, they envision life on Mars and plan to 3D print their way to it. But more on that later. If Relativity Space is successful, it will definitely give Musk and SpaceX a run for their money. While companies like SpaceX have worked to make space travel cheaper with the use of reusable rockets, Relativity Space will be printing reusable rockets that are simpler and cheaper to produce than all the others. According to Josh Brost, the Vice President of Business Development at Relativity Space, The use of 3D printers enables Relativity Space to quicken a significant portion of its manufacturing procedures and easily make changes to improve the rocket's design if necessary, even after it is taken off. This eliminates the need for a complex supply chain that would otherwise slow down rocket upgrades. But before we get into more details about this amazing rocket, let's take a look at how 3D printing works and how Relativity Space is capitalizing on this technology to create its peculiar rockets. 3D printing has been changing the way we produce products across every industry, from clothes and toys to tools and even body parts. 3D printing falls under the category of additive manufacturing, and it involves printing an object layer by layer, kind of like building an epic sandwich. The first layer is a slice of golden ciabatta. The second layer is a tasty aioli. The third layer is a perfectly grilled slice of chicken, followed by a layer of bacon. And then, what are we talking about again? Oh, right, rockets. So all of these layers are heated at just the right temperature so that they seamlessly meld together into the perfect panini, or whatever it is that you're printing. The 3D printer works off something called a computer-aided design, or CAD. The CAD is what the 3D printer will print. It is a digital model of the object, and the autonomous robots responsible for printing follow the CAD with exactness, printing each and every layer flawlessly, according to its specifications, down to a fraction of a millimeter. To create a CAD, you need a design-optimized computer, making the computer a necessary component of the 3D printing process. 3D printing is priceless when it comes to manufacturing quick prototypes, as it really shines in scale modeling. Early 3D printers were limited by size and substance, but Relativity Space has overcome these limitations to create the world's first 3D rocket. To do this, Relativity Space used its 120,000 square foot factory, the Portal, as it's known, and its Stargate printers. Stargate is arguably the world's largest 3D printer, and the device is able to print objects that are up to 120 feet, or 36.5 meters long, and about 24 feet, or 7 meters wide. While earlier versions of Stargate printed vertically, the newest generations print horizontally, allowing Relativity Space to speed up its manufacturing to be 7 to 12 times faster. Relativity Space and its Stargate printers are definitely disrupting the aerospace industry, but aside from rockets, there have been some other pretty ridiculous things that have also been 3D printed. For example, wall climbing robots, ironically 3D printers, mouse ovaries, skin, unborn babies, look it up, an entire building.
What?
Yes, buildings. Relativity Space already has plans to create 3D homes. As we mentioned earlier, just like Musk and SpaceX, Tim Ellis and the Relativity Space team had the vision to expand humanity's horizons and aid in human colonization on other planets, thus helping humans become an interplanetary species. To achieve this, Relativity Space is working on ways to build completely 3D printed army bases, homes, and a host of other objects required for rapid establishment of a society on an alien planet. NASA is also very interested in 3D printed homes. In response to NASA's Centennial Challenge, the international architecture firm, Hassel, in collaboration with Eckersley O'Callaghan, created the winning entry for a 3D printed habitat on Mars. The entry imagines the use of a protective outer shell built by robots, within which astronauts will be able to build their own homes. The shell will be made from materials sourced on Mars itself, as those are the only materials capable of withstanding the meteorite strikes and harsh radiation that the red planet is known for. Other architectural studios, like AI Space Factory, are also throwing their hats in the ring. Their 3D printed, beehive-shaped human habitat is designed to survive the harsh conditions on Mars, and has already been endorsed by NASA. So back to the Terran 1 and more of the ways it is employing the magic of 3D printing. The Terran 1 will use a Methalox-powered rocket, the first ever to do so. Methalox is a mixture of oxygen, and yep, methane. Please don't force us to make a "can I launch a rocket with my farts" joke. The launch of the Terran 1 will be in 2 distinct stages, and both stages will be powered by 3D printed engines. To be more precise, 9 Ion 1 engines that can produce a power of 900 kilonewtons, and a single optimized ion vac engine that can produce a formidable 1 meganewton. The future of 3D printing and its relevance to our interplanetary exploration rests heavily on the success of Terran 1. While it has been repeated several times that no startup has ever gotten it perfect the first time, we'll keep our fingers crossed for Relativity Space. We hope that good luck, have fun, will be a resounding success, sealing our new and exciting 3D printed future. 3D printing will also play an important role in NASA's plan to colonize the moon, but that's a story for another video, so keep your eyes glued to our channel. Do you think Relativity Space can challenge for the top spot and knock SpaceX out of position? Let us know in the comments.